So now we start with section 5.2 on compound interest. So with simple interest, you earn interest on your original investment. So whatever is the amount that you invest originally, you just earn interest on that. Now with compound interest, you earn the interest on the original investment and on the previously earned interest. So now let's look at an example of how it differs. So suppose you deposit $1,000 at 5% annual interest. Now your balance at the end of each year is shown in this table for both simple interest and compound interest. So this is the table for simple and this is the one for compound. Now if you look at end of year 3, you will notice that your bank balance would be $1,150. But if it is a compound interest, then your bank balance would be $1,157.63. So this is more and correct because you are now earning interest on your original investment as well as the interest that you had been earning in the previous years. So clearly the compound interest results in investments to grow faster and is fair. All bank saving account nowadays give compound interest and it is compounded daily. So every day at the end of the day, your interest is computed and added on to your balance. So again, let's look at the timeline. So this is t equals 0 and this is certain time. The amount at this time is called present value and in the future it's called future value. So the notations are sort of similar except for a couple of big differences. So future value is also called the compounded amount. Present value is obviously your initial deposit. So suppose your present value is $1,000, that's what you deposit initially. T is the time in years, so that is the amount you have waited. So suppose that's 5 years. And R is the interest rate per year. Okay, so R is, let's suppose, 6%. Now here is the new thing. M is the number of compounding periods per year. That means that many number of times in a year there is compounding. So we'll look into this matter again very soon. So now once we have decided M, it's always known beforehand, we will need two new terms. So the first one is N, which is the number of compounding periods in T years. So how many compounding periods will there be for the time that you are interested in? And I will be the interest rate per compounding period. Now the formulas for finding this are as follows. N is M multiplied by T and I is R divided by M. So let's look at an illustration, an example, and get comfortable with this idea. So first thing is to get M. So what does M really mean? So M is the compounding periods per year. So suppose somebody says the compounding is annual. That means M is 1 because that means one compounding in the year. If it's quarterly compounding, that means every quarter your bank balance gets compounded, then M is 4. Now if your compounding is monthly, that means M is 12. And as I mentioned earlier, your bank account compounds daily. So if the compounding is daily, M is 365 because there are 365 compoundings in a year. Now M is always, this is always known. So from there we have to compute N. So N is the number of compounding periods. So suppose an investment is compounding quarterly, so I know M is 4, and your investment is for 2 years, then the number of compounding periods would be 4 times 2 because there are 4 every year and you're waited for 2 years, so you have 8 periods. So N is 8. So that's why we have this formula, N equals M times T. Now I is the interest rate per compounding period. So suppose your investment is compounding quarterly, so that means M is 4, and your interest rate is 8% per year. Then the interest rate per compounding period, that means per quarter, would be 8 divided by 4, which means 2%. So that's why we have this formula. So you have to be comfortable in using and finding N and I for all the compounding interest problems. Now the compound interest formula is the following. So I'll write it here. Future value is present value times 1 plus I raised to the power n. So notice it is very different from the simple interest formula. Just to remind you, in simple interest, there was no exponent. Your future value was simply present value times 1 plus RT. But now, your future value is present value times 1 plus I raised to the power n. So we have to be quick and comfortable in using the calculator to find these quantities. So let's look at the first example. An investment of 2000 is deposited for 5 years in an account which is paying 6% compounded quarterly. So let's write down the information that is given in this question. So present value is $2,000 because that's what is deposited now. Time is 5 years. R is 0.06 and M is for quarterly. This is the new thing that you have to get comfortable with. So once we have this information, then the first thing, as we agreed, is to find I, which is R over M. So that would be 0.06 over 4, and you could use your calculator to find this to be 0.015, and N, which is M times T, which gives us 4 times 5, and that is 20. Okay, so the first thing is to find the compounded amount after 5 years. That means we have to find the future value, which we know is given by this formula. So we can plug in all the quantities. So that gives us 2000 times 1.015 raised to the power 20. And now using your calculator, you will find that this is 2693.71. So that means $2,000 will become $2,693 in 5 years. The next part of this question is, what is the amount of interest earned? Well, we have our present value, which means the original deposit, as $2,000, and we know it becomes 2693.71. So if we subtract these two, we will get the interest earned. So interest is future value minus present value. That's just common sense. And if you do it, you're going to get 693.71. So this is the interest earned in this account. Okay, let's look at the next question. A bank is offering CDs at the interest rate of 2.8%, which are compounded at different time periods. So if $10,000 are invested for 1 year, what is the future value, which is also the compounded amount in each case? So for each of these three questions, the present value is $10,000. The interest rate is 0.028. The length of time is 1 year. So the only difference is M. So in each case, M is different. So in part A, since it's annual, M is 1. If M is 1, my I, which is R over M, is 0.028, and N, which is M times T, is obviously 1 times 1, which is 1. Therefore, future value, which is this formula, is going to be 10,000, 1 plus 0.028 raised to the power 1, and that is going to give me 10,000, $10,280. So if it's compounded annually, your future value is $10,280. Now if it is monthly, then M is 12. In that case, I, which is R over M, is going to be 0.028 divided by 12. So that comes to 0.00233. We should keep sufficient number of decimal places to get accurate answers. N is MT, so that would be 12 times 1, so that's 12. Therefore, future value is 10,000 times 1 plus 0.00233 raised to the power 12. And when you use your calculator and find, you will see that it is 10,283.62. So you would notice that it's more than the previous part because the compounding is now done monthly. So the more number of times the money gets compounded, the more is the future value. Now let's look at the last one. If it's daily, then m is 365, and again we have to find I, which would be 0.028 over 365, and that's going to be really small number. So it's best if we use the calculator to do it when we are ready to plug it into the formula. N was mt, so that would be 365 times 1. So the future value would be 10,000 times 1 plus I, but I would be 0.028 over 365, and then raise it to the power 365. So use your calculator carefully, and when you do that, you are going to get 10283.95. That's slightly more than compounding monthly. Now there are a few things that are worth remembering, and so I've made a list of them here. I'm going to read them, but you should read it more carefully. So the first point here is that note that the compound interest formula does not use T or R like the simple interest formula did. Here we use N and I. And to compute this, you have to identify the number of compounding periods per year. That means in all these questions, you should always carefully find what M is. Then use the formulas given above to compute N and I. Now, use of the calculator will be extensive, so please become acquainted with all the features of your calculator, and you should maintain 4 to 6 decimals during intermediate calculations to avoid errors in the final result. So that means, for example, here when we were finding I, we should keep at least 4 to 6 decimals. So here I kept 5 decimals, so you have to be careful about it. Finally, let's look at the concept of continuous compounding. So what this basically means is that if the compounding is continuous, that means every instant, that means m is infinity. But if m is infinity, we cannot use the earlier formula. So the formula becomes this. We are not going to go into the math behind it, but instead of the previous formula, now we have future value is present value e raised to the power r times t. And of course, from the previous chapter, you know what e is. So we have to use this formula. So here's a very simple example of using this formula. So $5,000 is invested. R is 4%. You have to watch out for this word, continuously, for 5 years. So my present value is 5,000. R is 0.04 and T is 5. So very simply, future value would be present value times e raised to the power RT. So that is 5,000 e raised to the power 0.04 times 5. And again, it's a simple matter of using the calculator. If you do it, you're going to get 6107.01. So 5,000 will become this amount in 5 years. So now we're going to look at the idea of zero coupon bonds, and this is another common way that the companies borrow money for their use. Uh, Earlier on we saw what were called corporate bonds. Now we are going to look at what are called zero coupon bonds. Now this is very common and is very interesting as well. So let's read first. These bonds do not make any interest payments over the life of the bond. Instead, the investor receives the face value, which is also called the future value, when the bond matures. Hence, the investor purchases it for lesser amount, and that is called the present value or the purchase price of the bond. So what this means is that the face value that the bond has is the original investment, which is the present value, plus the interest that is earned over the life of the bond. So the zero coupon bond has associated with three pieces of information. Now this time let's suppose that Amy is the investor who is buying these bonds. So suppose this is that piece of paper, a zero coupon bond. So it has a face value. Suppose the face value is $10,000. So this is the amount that will be returned to Amy at the end of maturity. So it's called the future value. Then maturity. So maturity is obviously like the life of the bond. So suppose maturity is 5 years. So this is the length of time that the money is borrowed and is also called the life of the bond. Then there is an interest rate R, and that is given, which is, let's suppose 6%, and it's compounded. So M is normally 2 unless the question mentions it. So the default is semi-annual. So the idea is this: if you look on the timeline, so here is the future value, which is the face value, which is $10,000. So the question becomes, what is the present value? What is the purchase price? So that amount becomes $10,000 when it earns our interest, which is compounded at M equals 2. So the purchase price of the bond is the present value and the face value is the future value. So let's do an example and then it will be clear. So Peyton bought a 15-year zero coupon bond of face value $10,000, which is paying 4.4% interest compounded quarterly. So what was his purchase price? In other words, Peyton has a bond for 15 years. Now he's going to get $10,000 after 15 years. The question is, how much did he buy it now for? So what's his purchase price? So it's pretty straightforward if you understand how to set it up. So remember, we agreed face value is the future value. So I know the future value, which is 10,000. Then I know my usual stuff R, which is 0.044. I know T, which is 15 years. And then I know M, because it's compounded quarterly, M is 4. Now with these three numbers, I can find my I. I would be R over M. So that is 0.044 over 4. So that's 0.011. And then N is M times T. So that's 4 times 15. So that is 60. And what do we want to find? The purchase price. Purchase price means the present value. So purchase price of the bond is the present value. So we use our compound interest formula, FV equals PV times 1 plus I raised to the power N. And sometimes we know this, sometimes we know this. Depending on what we know, we can find the other term. Okay, in this case we know FV, so let's substitute 10,000 equals PV times 1 plus 0.011 raised to the power 60. This number you can find using your calculator, and if you do it, you're going to get 1.9278. Let's keep 4 decimals accuracy, and therefore PV would be 10,000 divided by 1.9278, and that gives us 5187.17. So that means Peyton is going to buy this bond for this amount, $5,187, and if he waits for 15 years, he's going to get back $10,000. So that's how zero coupon bond works. Notice that there was no check in the mail kind of stuff, and its earnings, the interest, is built into the price. Let's practice one more example. Now Mary Ellen bought a 10-year zero coupon bond, so it's 10 years zero coupon bond for $18,200 at 3.2% interest, compounded semi-annually. So now the question is, what is the face value of this bond? So let's see what all we know. This time we know present value because that's what she bought it for, $18,200. R is 0.032. M is 2 because it's semi-annual. And time is 10 years. So as always, we are going to find I, which is R over M, so that's 0.032 over 2, so that's 0.016, and N, which is MT, is 20. So once I know these, I can go to my compound interest formula, and let's see what all do we have. This time we have to find the future value. See, the question says what's the face value of the bond. So I need FV. I know present value, which is 18,200. 1 plus 0.016 raised to the power 20. Simple arithmetic, and if you do it, you're going to get $25,000. So that means Mary Ellen is going to get $25,000 after 10 years if she puts in $18,200 now. Finally, in this section, we are going to study the concept of effective rate. It's also called APY. It's also called APR. So you may have heard these phrases, and if you see some ads in the newspapers, they always write what is the APR. So what's this idea of APY or APR? It's called effective rate or annual percentage yield. So this is the simple interest rate needed to produce the same amount of interest in 1 year as the nominal rate does, with more frequent compounding over 1 year. So what that basically means is that it is the effective rate accounting for the compounding. So if things compound at different rates, it's difficult to compare which is the better investment. So this way we can make such comparisons. The formula is very simple. This is the formula for it, and let's practice it. So let me write it again. R effective is 1 plus R over M raised to the power M minus 1. So let's find the APY or effective rate if somebody tells us 12% compounded monthly. So what is actually the actual rate in this case? So for number first part A, RE would be 1 plus R, which is 0.12. M is 12, it's monthly, raised to the power 12 minus 1. So it's a simple matter of using your calculator, and if you do it, you're going to get 0.01268. Not 0.012, you're going to get 0.1268. So that means it's 12.68%. So a 12% interest compounded monthly actually is 12.68% annually. Okay, let's look at the next one. This time it's quarterly. So 1 plus 0.12 over 4 raised to the power 4 minus 1. Again, simple to use your calculator. If you do, you're going to get 0.1255. So that means that's 12.55%. So notice that a 12% interest, if compounded quarterly, results in only 12.55%, and if compounded monthly, it's 12.68%. Now this is very important in the concept. For example, in this next and the last example. So you have a bank which is offering 2 CDs. So one option is that you have a 8% annual interest rate and it's compounded yearly. The other one is 7.9% and compounded quarterly. So because the compounding is at different rates, it's almost impossible to compare the two. So the approach is to find the effective yield and then compare them. So let's look at option A. What is the RE? It will be 1 plus R, which is 0.08 over the compounding period, which is 1, raised to the power 1 minus 1, and that comes out to 0.08. Okay, so that's for option A. For option B, RE would be 1 plus the interest rate is 0.079 and M is 4 because it's quarterly, raised to the power 4 minus 1. Now again, if you use your calculator, you're going to get 0.0824. So that is the effective yield. So therefore, which CD should you invest in? Now 0.0824 is obviously better than 0.08. Therefore, option B is better. You would invest in the option B. So the point here is that although the nominal rate of option B is 7.9% and option A was 8%, so it seemed like option B is inferior, but because of more frequent compounding, quarterly compounding, the effective interest actually comes out to be 8.24%. So that's better.